Which is the best book to start with topology? How to study topology? What mathematics do I need to know before I start learning topology? In which order shall I read the books? What is the method of studying topology? In this video, I'm going to answer all these questions and give you a complete roadmap, a guideline to study topology. Considered to be a very difficult subject, it is important for you to learn the subject in the right way, in the right manner. So I'm going to give you a complete details of each and every book that I shall discuss in this video, and how and what are the YouTube lectures you should watch. My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to this lesson 17, where we are discussing about introduction to topology on the best books and the study method. So let us quickly see what are the topics that we are covering. So first we will see what is the importance of topology, what are the branches of topology, what mathematics prior to learning topology do you need to know, and what are the related books for that, the details of each and every book so that you can learn better. What are the best books in topology? What are the topics that are covered in those books? What should be the sequence of reading those books and why you should read, and what are the best YouTube lectures on topology? So given this kind of a idea, we are starting this video. First, what we need to know is the importance of topology. You will often see that a subject is considered to be difficult or boring, or students are unable to understand because they don't realize what is the importance of topology, what is the importance of the subject. So in this part of the video, I'm going to show you exactly how important topology is in terms of your career building, business aspects, research and facility and other, so that once you understand the importance, you won't feel that topology is boring. So the first thing, importance of topology, is that you need to understand that topology is basically concerned with properties of geometric objects that are preserved under continuous deformation, such as stretching, twisting, etc., without closing holes, etc. There are certain rules. So what I'm trying to tell you is that this is a kind of an tool which enables physicists and mathematicians to study the properties of object. Now, what do I mean by that? What I'm trying to tell you is that the usual way of studying geometry, which are the polygons which are there in the Euclidean plane, gets, I would say, generalized into certain different kind of shapes. So as you see on the left hand side, these are Euclidean polygons, and on the right hand side you see non-Euclidean shapes. So once these polygons, which are being stretched or deformed into non-Euclidean different kind of shapes, the advantage is that we can do and we can use those deformed shapes in various fields of mathematics and physics. We can study those shapes, we can study their characteristics, their structures, so we are not restricting ourselves to a particular coordinate system, but we are becoming coordinate free. So here you see, despite these deformations, some of the properties remains invariant, which helps mathematicians to do the measurement. And this generalized concept helps us to extend the properties of Euclidean geometry to other spheres of mathematics. If you go back to my earlier videos on topology, you will see that I have discussed in details what do we mean by generalization and how generalization helps to apply those rules of geometry and mathematics into a wider field. So this is basically the root, the reason that we study topology, shapes which are being deformed so that we can use in different areas. The question is that, is it only related to mathematics and physics and only related to the books that we study? Let us look into the next part of the video. So you see the application of topology first is definitely in the area of physics, where we deal with different type of structures and then we study the physics of those structures. It is also very much related to geometry, because you see that the entire sphere of geometry has changed from Euclidean to non-Euclidean, where we are not specified, or I would say very much restrictive in a particular coordinate system. We are much more open, we are much more global, and these structures of global structures and shapes helps us to apply them. What are the applications? Say for example, the first one is digital image processing. Now you see that nowadays digital images are becoming one of the key means of communications while dealing with graphical information. So the images in digital camera, they are a demonstration of words in a, I would say, book or comics or graphics, are the examples of digital images. So the area of digital image processing deals with the storage, the formation, the operation and demonstration of images. So for every phase of digital image processing, topological concepts and tools are involved and solve many questions and problems. The main role play by digital topology, where the topological setting is the digital plane, which is a space acquired by taking the product of two digital lines and so on. So digital image processing is taking help for topology, and as we see nowadays with social media coming up, digital image processing is very important. The next application comes to biology. Now topology, besides being a very different branch of mathematics, it plays a very good role in biology, since genotype and phenotype are of very primary importance in biology. We see how topology is very useful in sequencing the right nucleotides in a DNA strands. So genotypes are internally veiled and inheritable information of a living being, while as phenotypes are the physical appearances of that information, and topology solves one of the most important problem in DNA research. Robotics, topology and physics have a very deep connection. It requires the most advanced knowledge of topology to study the sophisticated applications of physics. For studying configuration space, we have to sometimes track variables that are related to position and arrangement involved. For example, we may need to keep the track of the various part of the robot's arm. So the configuration space, which acts as the topological space, facilitates us to achieve this type of tracking facilities. Yes, civil engineering, topology has got application to civil engineering also, like we have one in bridge design. So bridge design is given by topological optimization technology, and topology optimization is better aimed for location and shapes of cavities in the design area. Lastly, very important, geographical information system or GIS is a computer software which has the ability to store, operate and accumulate geographical information, and topology in GIS is used in analyzing the spatial relationships among different contours and regions of that area. So you see that now that you have understood that what exactly topology is all about, or what exactly is the direct applications of topology, I'm sure that you are quite motivated to learn topology, because it is not only the books and those difficult formulas and proof system, but it is something related to our daily life. So the importance is very widespread. It has got a huge amount of scope, because nowadays in US and UK you will see that a lot of people are specializing in topology. It has got industry friendly appearance, and it is a very emerging field of study, less competition, so we can definitely feel motivated to learn more about topology, and it has got an industry application also. So in this part of the video, what we have done, I have told you in short what is topology, why we should learn, and what is the importance. This is primarily the most important thing, because most of the students, they jump into topology unable to understand, because they lack the motivation and the direct hands-on application of topology. Right. So first we need to understand, when we are going into topology, what are the different branches which are involved, because the books that we will be talking about depends upon the branches. So topology can be broadly divided into general topology, algebraic topology, differential topology, and geometric topology. Geometric topology further can be subdivided into lower dimension and higher dimension. Now note that we are not dealing with all parts of topology, but the books that I would be talking about would be on general topology. So general topology is basically, old name is point set topology. It is the basic concepts of topology. In general topology considers local properties of space, etc. So we use set theory to do the calculations. Foundations of different topology like geometric and algebraic topology starts with general topology, and you see this compactness, product spaces, open balls, disconnected paths, metric spaces, topological space. All these technical terms, or the terms that we use, are related to general topology. So just a point to those viewers who are watching this video, the books, the methods of study, whatever we would be discussing right now will be based on general topology, because if you know general topology, the other topology becomes easier to learn, and we will also understand the basic roots of all those topologies. Now if you're really interested to know more about those topologies, the different branches, I would recommend you to go to this video, which is there in the playlist lesson number 10, where I have talked about more about what those topologies all about, a little bit about the history of topology, the different branches in more details. Okay, so the first question comes that what mathematics do I need to learn topology? Because you understand topology is not like just differential geometry or calculus or real analysis. It requires some amount of good mathematics to learn. So in this part of the video, we are going to look into what are the mathematics that we need to learn, how and what is the sequence of learning, and what are the books that you should look for. So the first will be definitely calculus. I don't need to mention, this is building the basic foundation. Next would be definitely linear algebra. Third would be set theory, because extensively all the logical quantifiers etc. dealt in, so set theory for writing proofs. The next would be real analysis. Yes, very much important, real analysis, because topology is all about proof-driven system. Then definitely we need to understand differential geometry, because it deals with local geometry and manifold. If you want, you can go back to my video where I have talked about differential geometry and topology, which one should be learned first. Yes, definitely differential geometry and group theory if you want to learn algebraic topology. Okay, now given all those prerequisites, I would like to tell you that this calculus, okay, and any proof-based mathematical system, because topology heavily depends upon proofs. So if you have done a refresher course or anything on any kind of a proof-based mathematical system where you are writing those proofs, deductions, definitions, that would be great. Now see, all above that, what requires a kind of a mathematical maturity. That means you can have a mathematical maturity which is very difficult to define. Somebody attends at 16, Terence Tao might have attended at 16, somebody attends at 61, somebody never achieves it during their lifetime. So a kind of a mathematical maturity to understand, perceive, have a kind of an abstract thinking is required. So these are the prerequisites. Out of that, calculus and set theory I won't mention in this video, because this is too naive, too elementary. You can get hold of any book of calculus of Thompson's and others, and definitely set theory. I'm sure that by the time that you're watching this video, you might already know calculus 1, 2, 3, 4 and set theory. So what I would do is that I'm going to mark those based on the priority. That means which one is most important. Number 1, set theory. Number 2 is any proof-based mathematical system. Number 3, yes, very much real analysis. And number 4 would be differential geometry. So these numbers are basically given based on what is the sequence or what is the importance you should learn. So definitely you should start with set theory and get into any proof-based mathematical system, then go into real analysis and learn differential geometry. Most important is that what are the books or what are the best books for these mathematical prerequisites to learn. So as I told, we are done with calculus and set theory. I will start with linear algebra. On my channel Physics for Students, there is a quite amount of good linear algebra videos, although they mention as mathematics of quantum mechanics, because quantum mechanics also require linear algebra. You can watch this on my channel. There are a good amount of videos in my playlist mathematics of quantum mechanics, and you can learn linear algebra very well. Other than that, these are few of the books which I would recommend. Gilbert Strang, then Sheldon Axler, then George Isherlob, and a little bit advanced book of Sir Glang's Introduction to Linear Algebra. We move on to the next, real analysis. I have got a lengthy video which speaks about real analysis. As you can see, 42 minutes. Go through that video. Everything is detailed out, the way of study, the plan, what you should learn, what is the process, what should come first, everything about real analysis. Coming to differential geometry, very recently I made a video which is called How to Study Differential Geometry. You can see there are almost 15, 16, 14 odd good amount of differential geometry videos. You can go ahead and read those. But this video which I am telling, lesson number 13, this is very exhaustive and it contains all the different books. How will you get those books? What are the best books? What to read? Everything about differential geometry. One video which is going to give you a complete understanding about the approach and the study. Okay, now we come to the central part of our video. What are the best books on topology? Now, before I go into explaining those books, I would like to mention that these books, it is not that you need to have all of them. It is not that you need to read all of them. These are a kind of a list which I have read, and I have found that these books are the best. Maximum you can read 1, 2 or maximum 3, you are done with topology. So there should not be information overload. There should not be that you want all those books and it is there on your hard drive or you have purchased it or anything. No, just these are the names of the book. You can pick and let me know which book you want. So the first thing is that regarding the books I would like to tell, there is one type of book which specifies on topology on metric spaces. We are going to look on that. Why metric spaces? Because metric spaces are much more easier to understand. The second is that there are certain books which assumes that you know the essentials. That means all that I talked, differential geometry, real analysis, set theory, everything you know. And the third type of book is called a self-complete book, and we are going to look on those books. That means those books which assumes that you know anything, and it teaches you step by step and then goes into topology. So the first book coming up is obviously the great Munkr's topology, right? This has got a customer review of about 5-star, and this is the famous Professor James Munkres. So in this book, actually, why I recommend first is that it covers everything. You see, it starts with set theory and logic, fundamental concept, functions, relations, everything. Once you learn set theory, then it moves into topological spaces on the right hand side, basis for topology, product, metric, etc. Then it goes into connectedness and compatibility and other things. Then you see it covers up the complete metric spaces which I was just talking about. It covers a lot about algebraic topology, homotopy. The part 2 would be a little bit advanced, and then it finally ends with the applications to group theory. So my summary of Munkres' book is that it is the best book for beginners. It assumes nothing. It teaches you everything that is required. It is easy to read with illustrations, and classically it is considered one of the best books to start with on topology. So first would be my recommendation on Munkres, but don't think that this is the way you should learn. This is just the books. I will come to the sequence of reading later in this part of the video. Second one is Topology Without Tears by Professor Morris. Now the problem is that you won't find it in Amazon. It is available free on internet. I have been in touch with Professor Sidney Morris. He has created a YouTube channel also where he is explaining those concepts of topology. So it is a wonderful book. So you see, it starts with introduction, goes to topological spaces. Most importantly, it starts with Euclidean topology, because until you understand the base Euclidean topology, you won't understand the other things. So limit points, homeomorphisms, goes ahead, followed by continuous mapping, metric spaces, finite products, and then it ends with the Weierstrass theorem and quotient spaces. Now, my take of this book would be that it is definitely a very good book to start with. Examples or proofs are easy to understand, but this book does not teach you with the necessary mathematics. It directly jumps into the proofs, and it contains hardly any illustrations or diagrams. So these are the, I would say, the cons, the problems of this book, because if you're not aware about those proofs, you will find it very boring, because it starts readily with the proofs and it hardly has any diagrams so that you can visualize. The next recommendation of my books would be Bert Mendelssohn's Introduction to Topology. As you see, it is given a 5-star or 74%. And the beauty of this book is that it starts again with the theory of sets. So it assumes nothing, right? Then it goes into metric spaces, then it goes into topological spaces. It is also dealing with connectedness and applications of connectedness and so on. Further, it deals with compactness and it ends. So around 200 pages of book, very compact. It doesn't speak much about anything, but it is a very good book. So what I would like to summarize is that it starts off covering the basics of set theory. Chapter 2 covers metric spaces, which gives definitions of open sets, neighborhoods, open balls, etc. The exercises are very interesting, right, useful, and you will find at the end of the section. And the book is structured into manageable chunks, and the topics are well explained with lots of questions. That means it actually gives you in small chunks so that you can read step by step. Okay, my next recommendation for the book would be Introduction to Metric and Topological Spaces with Wilson S. Sutherland. It has given a rating of 68%, but I think it is a wonderful book. It should go up to 80%. This is Professor Sutherland's picture. But why I'm coming to metric spaces? Because as I told you, metric spaces are easier to understand. So you see, the beauty of this book is that it starts with this one. It will review about real analysis, right, real numbers, real sequence, continuity, limit, etc. Then you see it comes with metric spaces, more concepts on metric spaces. Then it will start with topological space. Then professor goes into continuity, and then Professor Sutherland explains about Hausdorff condition, connector spaces, etc. So as I was talking, you see set theory, real analysis, etc. So here you see that real analysis is being covered. Further, Professor Sutherland explains about the circle, torus, uniform convergence, and the complete metric spaces, finally ending with Banach's fixed point theorem. So what I would like to tell about this book is definitely it covers the necessary real analysis. It is very well designed with easy to understand, and one of the best introductions to metric, bearing in mind that it's an introductory book, and it is an excellent text for the second or third year graduate students studying mathematics, and it does not require much mathematical maturity, as I was telling, to read, but it is not honest about results. So there is a it is a sense of a balance with the complexity, etc. So it gives real analysis. It is comprehensive, it is well designed, it is structured, and it is one of the best book for the introduction to metric. Okay, my next book would be this one, the great book From Geometry to Topology by H. Graham Flegg, and the rating is 54%, again quite underrated. It should go above 80%. Now, before I go into the content of the book, I would like to show you a very important part, that is the author's preface. Now, you see I have underlined certain lines in red, which tells that the many universities courses in topology plunge immediately into a formalized and entirely abstract presentation, as I was telling. And it is difficult to understand. So you see it has been underlined that it is often insufficient time available for a more intuitive approach. So the first 3 chapters of the books provide a link from geometry to topology by considering equivalence classes defined by various suitable transformations in the real Euclidean space. And the general theme here is that by increasing the number of permitted transformations, the congruence classes of Euclidean geometry are gradually enlarged, and the common topological properties remaining within these enlarged classes are eventually highlighted. That means it takes such a beautiful step-by-step approach that the transformation from the Euclidean are first taught in the Euclidean classes, and then slowly it is being highlighted and enlarged. let us quickly look into what the topics he is covering. So Professor Graham first covers, the basic congruence class. You might be thinking that am I reading school level geometry? No. Then it starts with non-Euclidean geometries. It moves to geometry and topology. It starts with surfaces and moves into connectivity much later. So you see 1, 2, 3 is basically the building blocks of this book. Then it goes into networks and coloring of maps and Jordan curve theorem. Further, Professor Flegg explains about plane diagram, the standard model, continuity, functions, and so on, finally ending with metric spaces and topological spaces. So you see the metric spaces and topological spaces comes much later in this book, because this book believes in building the base strongly, whereas in other books you will see that metric spaces comes almost at the middle of the book or at the starting. So what my take would be that this is an excellent introduction to topology. The only prerequisite are high school algebra and geometry. It is most practical motivation from geometry other than any other book, and it is a marvelous read, and a chronology on development of the concepts are given. Okay, now we will move to the next part of our book, which is this one. Again, this is metric spaces. It is by S. Kumari-san, and this has given, I think Professor Kumari-san was actually was at Tata Institute of Fundamental Research, received a lot of awards, and he was basically into topology. 70%, I think, well, it is fine. So you see, it starts with basic notions, convergence, continuity, compactness, connectedness, and he completes the metric spaces. So this is a book, again, it is easy to understand because topology with metric spaces are far more easier. So what I can tell about this book is that it is a must read for those who wish to learn topology. It can be used for second reading. It is also a book which gives detailed explanation on each and every concepts of matrices. Every student should be able to read it. My last recommendation would be Introduction to Geometry by Professor Ballman, and you see this book is very coincised, and it starts with the first steps, a little bit advanced. It goes into manifolds, differential forms and cohomology, the geometry of submanifolds, and so on. So that is why I kept the book at the last, because it is little bit advanced, which many people maybe will be finding it difficult. So this book contains solid introduction to the subject like differential topology and differential geometry. It's a good textbook for a great resource. It's the first section on topology is used for developing a geometric point of view. Okay, now that we have seen lot of books, now the question is that, say for example, we are studying all those books. What is the sequence of the study? So the first would be From Geometry to Topology by Professor Graham, because that builds up the base very strong, where you can connect with what the geometry you have just learned. Second, obviously Mooncrest topology. Third would be, I would recommend, but once you learn the topology overall, you should go to metric spaces. So this would be Wilson or Sutherland. You can exchange in between first Kumari-san and then Sutherland anyway. And then you should be going into Bert Mendelssohn's Introduction to Topology. Then it will be Sidney Morrison's book. And then finally with Introduction to Geometry and Topology. So this is the sequence. And now it is not that you need to have all those books, but this is the sequence, I mean to say, of study, that you learn the basics, then you move into metric spaces, and then you go into the real part of the topology. Okay, so what are the YouTube lectures? Because we are quite familiar that there are great YouTube lectures on topology. Well, I won't be promoting myself or I am boasting, but I have got a good many lectures, around 16 on topology, and as you can see the number, so it starts with the basic of topology, then it moves introduction topology, there is isomorphism, homeomorphism and homomorphism, and the very recent Down the Rabbit Hole, which Professor Richard Sott also told that it has got a good amount of stuff. So you can go through my playlist on the YouTube lectures. Remember, mathematics is there, but mostly these lectures I have designed in order to make you intuitively aware and intuitively learn and visualize topology. So in my lectures you will find a lot of abstract ideas which are being explained through pictures, illustration, graphs, and some weird ideas which I thought would be useful for you, because learning topology is not the difficulty lies in mathematics but in visualization and understanding the abstract abstractness. So my lectures on topology, if you see those 16, are basically designed to make the basic thing strong, and lot of illustrations and photographs and pictures I have given so that you can understand better. This is a wonderful Professor N.J. Wildberger. Who doesn't know about him? Insights into Mathematics contains a good amount of YouTube lectures. The second will be Marius Futter's lot of details about topology. It starts with the closed set, open set, and you can see many lectures about topology is there. My next recommendation would be Elliot Nicholson's, because he had got a good many lectures on metric spaces and topology, although some of them are a little bit advanced, but it is worth going for. And then I would also recommend Daniel Chan Mads, because if you see her lectures, it is wonderful. He sometimes makes model of those lectures, and you can come up. So you see it starts with points in topology, topological spaces, and so on. Right. Now the question rises that this James Cook, this is a little bit advanced, but still you can go through it. James Cook's lectures are quite good enough. You see there is one undergraduate topology and then algebraic topology. So he builds up step by step. He goes very detailed into that, but these lectures are wonderful. Okay, now the question lies that how to get those books. Very simple. You can write to me at my email ID, or you can WhatsApp and chat or talk to me. And what I'm going to do, because these are heavy sized books in terms of megabytes, I will try to share it in Google Drive. So I will share it. You can download, let me know, then I will delete to save the space. So the fact is that what I would like to tell you is that please do not stuff, or I would say just hold on the books just for the sake that you have got so many books, but prioritize based on the sequence that I have told, and let me know what are the books that you want. However, I would be happy to send you all the books, but it is just information overloading. So make sure that you find out the right book, the right approach, and you go on learning those. So those who are watching this video, I would like to thank everybody. Please subscribe to my channel Physics for Students. Click on the bell icon to get all the notification from Physics for Students. You can contact me at this ID which I have just shared, contact@physicsforstudents@gmail.com. I also have an exclusive channel which I'm trying to grow, that is General Relativity Explained, where I'm explaining only and only about general theory of relativity and Einstein's field equations. You can also follow me here in Facebook, Instagram, and LinkedIn. So that's all for today's video. I think that you have liked it. Please do put up your comments. Let me know what are the books that you want. I would be happy to help you. Please do subscribe and share my videos as much as you can. And I would really thank from the core of my heart for watching this video. I think that it has given you a complete approach, books, study, etc. And in the next video, I would be coming up with what are the problem one faces while learning topology, and what is the method, and what is the sequence, and what are the different tricks and tips that makes your journey in topology easier. Thank you very much for watching this video. Stay safe and happy, and may good Lord be with you.